Hey guys, welcome to my end of 2024 live stream. For me, this is always like the strangest bit of the video where I'm like, am I started? But I sure that I am. And I mean, it's the depth of winter right now, so I've got these like massive lights so that we can actually see any of the work that I'll be doing today. And yeah, we're going to be going through quite a lot of mechanics and statistics questions, actually. I figured what we're going to do today is, yeah, try some of those kinds of questions. Because I think in the last live stream that I did, you can always catch up on my old live streams. I did mostly pure kind of stuff, but I have got a couple of submission questions that are from my Discord. So if you do ever want to submit any questions, you totally can do this as well. There's a link in the description about how you can come along to the Discord group and submit some questions. And the questions that have been submitted are very challenging, but also quite fun. And they're going to be some good things to kind of point out with some things as well. So first of all, hello to Azim. I can see Azim, who has been in so many of my live streams before. Thank you, .8. That's brilliant. And hello to everybody. Hello to Maths Forge. And good afternoon to you as well, Dan. I mean, it's weird, isn't it, when it's afternoon and it's like pitch black like this as well. So if you do have any questions as we're going, you can obviously respond to some of the questions that I'm going to be doing live in the chat as well, and I can answer any of those questions that we're doing. But also at the end, I don't imagine we're going to be doing like the full hour on these questions, although having said that, we're going to do some pretty tricky questions from the Discord submissions. I'll have some sort of like broader kinds of questions that I can answer as well. Yeah, let's get started really. So first of all, just, thank you so much for coming along. So, like I said, this stream is focusing on mechanics and statistics, plus some questions submitted from the Discord channel. So, the start off, the applied one, somebody has just asked, is this going to be year two math? It's actually some year one stuff for the applied questions, mostly because I think they're quite tricky ones that I've selected a little bit here and there. And then the A2 submissions are obviously year two stuff that we've got. Okay. So let's have a look about this first question, just to kind of do a bit of a warm up here. Because, I mean, I don't know about you, but at this point in December, I'm always feeling like really tired by everything that's going on. So I'm sure you can identify, you can tell me in the chat what this topic is going to be. And when we think about this topic, there's usually a couple of things that we need to watch out for. So I'll have a look in the chat in a second. What are the usual things we need to look out for when we're doing a question that looks like this? Okay, fantastic. So people have already told me this is stuff to do with like variable acceleration. And we've been told that the velocity of this particle v is equal to 15 minus t squared minus 2t. And we know when we have these things, we normally write like SUVAT, S-U-V-A-T. If you want to go down the list, we know that we differentiate. And if we want to go up the list, we know that we integrate. In case that's usually the sort of starting points that we have for this. And there's usually something I need to look out for. So might see if that comes up in this question, but we will see. Part A of the question is super simple. It uses the word verify. It says verify that P comes to instantaneous rest when T equals 3. So this means we can literally just substitute in T equals 3, and we should see that V is going to be equal to 0. Now, I'm not going to just put it straight in the calculator. I'm going to write 15 minus 3 squared minus 2 multiplied by 3. Obviously, 15 minus 9 minus 6 is equal to 0. And if you wanted to, you could say hence it is at rest, but I don't think that's really necessary for this 1 mark that we've got in this question. And then part B, nice easy one, it says find the magnitude of the acceleration when t equals 3. So we'll obviously be using this information that we've got up here, which is to go from v to a, we will be differentiating. So v is 15 minus t squared minus 2t, which means the acceleration, when we differentiate, 15 will go, the t squared goes to minus 2t, or the minus t squared goes to minus 2t, and the minus 2t just goes to minus 2. This is when the magnitude of the acceleration when t is equal to 3. So when t is equal to 3, the acceleration is minus 2 multiplied by 3, minus 2. That's minus 6 minus 2. Minus 6 minus 2 is minus 8. Now, it did say the magnitude of the acceleration. They do actually accept minus 8, but I would probably just go with 8 meters per second squared, because magnitude just means we're going to ignore whether it is positive or negative. Now, for part C of this question, it says find the total distance traveled by P in the interval 0 to 4. And I want you to think about why this question, we need to be a little bit more careful for this one here. Why do we need to be a bit more careful for this one? And there's a bit of a clue actually in part A of the question about having found out when it came to instantaneous rest. And while you're kind of doing that, I'm actually just going to get something up on my graphics calculator that might help us a little bit with visualizing this. Yeah, very good from Bryce Anderson. We've got that the areas are cancelling and the graph is going negative in this part. And so let me just show you what it would look like when we draw the graph. If I can put it on my graphics calculator, we can obviously see that it is going to be dipping below the axis. This is where 3 here. So after 3, it is going negative. We kind of knew that it was going to do that anyway, because of the fact that we said when t was equal to 3, b was equal to 0. So if I did want to draw what this graph looks like, well, I know that it's going to be crossing 0 when t is equal to 3. If you use the equation solver in your calculator, you'll find the other place where it's crossing, which is right here, is at -5, but you could just do that on the calculator. And so it's this kind of shape. And the part we're interested in is between 0 to 4. So we need to do that integration in two separate sections. We're going to do the integration between 0 and 3, and then between 3 and 4, like this is two separate parts. So the bit between 3 and 4 is obviously going to be negative. So we're trying to find out what the distance is, which means we're going to go from the v up to s, which is integration. So I'll start by integrating between 0 and 3, and it is 15 minus t squared minus 2t dt. So we get our square brackets, we'll get 15t. T squared is going to integrate to a third t cubed, and the minus 2t is just going to be the minus t squared here, and that's between 0 and 3. Now I'm going to be kind of lazy, or maybe it's not lazy, maybe it's the opposite, doing it in my head. I'll do 15 times 3, which is 45. Now, I know that 3 cubed, when you divide it by 3, is just 3 squared. It's going to be -9. And I'm also going to be minusing another 9 here. And when I sub in the 0 to all of these, obviously I'll just be taking away 0 all of these times. So 45 take away 9, take away 9. Well, that's just going to be 27. But, sometimes you do just want to check everything. 45, take 9 is 27. Okay. Now we're going to need to do the next part, which is it going between 3 and 4. This part I know is going to give me a negative answer. You know what though? I know what it integrates to, so it's exactly the same thing as before. That's 15t minus a third t cubed minus t squared between 3 and 4. And when I substitute in the 4 for this, I'm going to have to say that it's 15 times 4, that's 60. I am one of those sad people that just knows that 4 cubed is 64. And I'll be subtracting 16. And from that whole thing, I'm subtracting when 3 is substituted in. And I know that when 3 was substituted in, it was 27. So on my calculator, I would very quickly do you can sort of just about see it on my screen, the 60 minus 64 over 3 minus 16 minus 27. This is how I do my fractions, by the way. I never use the fraction button. I find it annoying. And so that is minus 13 over 3. But because we're doing this as a total distance that is being travelled, I'm going to say it's the 27 from this first part. And I'm just going to add on the magnitude of that part, which is 13 over 3. So 27 plus 13 over 3 is 94 over 3 meters. If you wanted to give it as a decimal, so we're going to do it to 3 significant figures, we could say it's 31.3 meters for this question. So pretty straightforward one. We've got the 94 over 3. We did get the 8 in this part of the question, and we also got to show that to that first part. So a nice easy warm up for this mechanics question, and then we'll have a look at this other one that was also taken from the 2023 one that we've got here. What have we got here from Zane? Just want to say on notifications, thank you for your video. You single-handedly got me 2 A stars in further maths and normal maths last year. That is amazing, Zane. Thank you so much for popping in and sort of sharing that with everyone. I'm really pleased that my videos have kind of contributed to people's success like that. Oh, Zane, I now recognize your profile picture. You used to leave loads and loads of comments and stuff. And hopefully I answered all of them. Hopefully it really helped you. Okay, so we're going to have a look at this next mechanics question we've got here. It says that a car of mass 1,200 kilograms is towing a trailer of mass 400 kilograms on a straight horizontal road using a tow rope, as shown in figure 2. The rope is horizontal and parallel to the direction of motion of the car. Okay, nothing interesting in that. I can literally just see the diagram. Nothing really there. So we're going to have a bit of a drawing here because I think the drawing is going to help us add on some things onto this. Now, I know they've kind of got them properly drawn, but I'm just going to do them as 2 boxes like this and this. This one is 400. This one is 1,200, and they are connected by some kind of rope that we have here. I'm just going to read all the questions. It says the resistance of motion to the car is 2R. So obviously this whole diagram is moving to the right like this. I'll just pull that down a bit. So that means that the 2R is going to the left because it's the resistance of the motion that we have. And then the resistance to motion of the trailer has a magnitude R. So I will just draw an R just happening to the trailer there. The rope is modeled as being light and inextensible, not that important at this stage. The acceleration of the car is modeled as A. Well, that's also going to be the acceleration of the trailer because it's an inextensible rope. It would be weird if the car was going fast, but the trailer was kind of sat stationary. And what else have we got here? The driving force of the engine of the car is 7,400. So I'll add that in here. And the tension in the tow rope is 2,400. Now, interestingly, the tension is going to act in these two different directions because the trailer here feels like it's being pulled forward, and the thing that feels like it's pulling it forward is that tension, whereas the car feels like the trailer is dragging back on it, so it also is experiencing that 2,400 that we've got. And this is the weirdest thing about tension. It is actually acting in all different directions throughout that rope at all times. Just depends on which kind of thing we're looking at as the point of view that we have here. Oh, very good to Sam as well. It's awesome to hear that you've got your predictions. Hopefully, it's all going to kind of come through to you as well. So now it just says using the model, find the value of A. Well, typically when I do these kinds of things, you can either consider the entire system or you could consider just one part of it. And then you could also consider the other parts of it separately. You can do either, like I said, the whole system or one part separate. I'm probably just going to start off by doing the, the trailer that we've got here. So for the trailer, it's accelerating, so I'm going to use F equals ma, and that's going to be my positive direction in this question. It's obviously the 2,400, that's the thing that's pulling it, minus the resistance is equal to the mass times by the acceleration. So the resultant force was 2,400 minus R, and then that's the mass times the acceleration. Then I'm going to do it for the car that we have here, so I'll do F equals ma, with it still going towards the right. So we have the 7,400, and then we're going to subtract from that the 2,400 because that's resisting its motion and the 2R, and that is equal to its mass times by its acceleration. So 7,400 minus 2,400, that is 5,000 minus 2R is equal to 1,200A. So all I need to do now is take this equation and this one and solve them simultaneously. I'm probably going to just half everything in this one so that I end up with 2,500 minus R equals 600A. And then I will take this one and this one. I'll do my simultaneous equations. I'll probably do that one, take away that one. Okay, so I will do this one, take away. Oh, not take away. Yeah, take away. I'll do this one, take away this one because the minus R will cancel with the minus R when we subtract them. So I will subtract, which just gives me 2,500 minus 2,400, that is 100, minus R minus minus R cancels, and we get 600A minus 400A is 200A. 100 divided by 200 is 0.5. So the acceleration is 0.5 in this question. So the value of A is 0.5. Then it says, in a refined model, the rope is modeled as having mass, and the acceleration of the car is found to be A1. So this time, we're now not imagining it with something that is light that is connecting them. We're imagining it with something much heavier. So we need to think about what is going to happen to the value of A1. What do you think is going to be happening with A1 here? And while you're doing that, I'm just going to read through the chat. You've seen I haven't started releasing all of FP2 for free. I have released the number theory chapter because I have just been, you'll see, there's a video I've got coming out at the weekend that I'm going to be sorting, where I want people to have an opportunity to go and have a look at the number theory stuff from FP2, but it won't all be free. It's just that part that we've got there. Yeah, you're correct, Bryce. It is going to be decreasing. And so I'm going to say A1 will be lower than A. It doesn't even give an explanation. It doesn't even say to give an explanation. But obviously, the reason that's happening is because if it's a heavy rope, the car is having to pull the trailer, but it's also having to pull a heavy rope as well, which is going to mean it's harder for it to accelerate. So it doesn't ask for a reason, but if we needed to, we could kind of say there's more mass that it's having to pull. And then it says, state one limitation of the model used for the resistance to motion of the car. So we can't critique the rope being light and inextensible, but it says the resistance to motion is modeled as a constant force of magnitude, blah, blah, blah. So I think the thing here is going to be that we shouldn't have modeled it as being constant. This is a pretty easily modeling kind of question. So one limitation of the model is the model uses constant resistance, which isn't realistic. So if we wanted to talk about this in a sort of broader sense, when something moves fast, the resistance gets actually a lot higher because air resistance behaves in that way. I think it's to do with the square of the speed, but you don't need to go into that level of detail for this. Okay. Oh, it's very good to see this. People got their mocks and kind of coming along to this to kind of use it as well. Now they will get harder. So if you're thinking this is just a nice warm up, you're right. It is a nice warm up. But we are going to do some much harder questions. I think the stats ones are kind of a bit harder. It's also the end of the year. I just thought it was nice to kind of check in with everyone and see how everyone's doing. So we've got those all correct in that part. Let's have a look at a stats question. Stats questions can be nice, but sometimes they can be a little bit trickier to kind of think through some of these things. So let's just have a look at this one and see if we can figure out what the topic is. I wonder if you can think what the topic is or what you might want to do in this question to begin with. That would be really helpful to see in the chat. It says, in an after-school club, students can choose to take part in art, music, both or neither. There are 45 students that attend the after-school club. And then of these, we get some information. 25 take part in art, 12 take part in both art and music. And the number of students that take part in music is X. And I've got a weird question I've never seen before, which is to find the range of possible values of X. Yeah, I'm seeing in the chat people are saying this is to do with like a Venn diagram kind of question. It just sort of really naturally feels like it's asking us to draw a Venn diagram. It feels like it's that topic all to do with probability and stuff. And I think this whole thing is representing the after school club. And if you go to the after school club, you either do art, music, here's art, here's music, both, or neither. You could go to the after school club and do neither of these things. Okay, so we've got to make sure that it's actually all of those. Yeah, everyone watching right now, A-star students. Yeah, if you're committed to coming to a live stream on the 10th of December, just before school is finishing, I very much believe that is true. So I'm just going to start filling in some of these things. It says 25 students take place in art. Now, I don't want to put the 25 here because there's two sections for the art part. So I'm going to say that 12 students take part in both art and music, which means I can put inside the art section, I can put the 13. So we have those two sections adding up to 25. And then it says that the number of students that take part in music is X. So this whole thing that we've got here is X, and this is 12. So this must be X minus 12 for this particular part. And we don't know anything about this part that is going on the outside. Okay, we don't know anything about that bit yet. But it does say find the range of possible values of X. So there's definitely something about this X minus 12. I know something about this X minus 12. What do we know about the X minus 12? I think there's going to be something important for that. And that'll give me a chance to just have a sip of my water. I don't know why. I feel like when I'm by myself doing these videos, talk so loud and I just get so thirsty with this. We do know about this. Do we know anything about the outside to Breezy? Do we know anything about the outside? What do we know about the outside? Okay, yeah, I suppose we do know that the outside is 45 minus 12 minus x. Yeah, we do actually know. So if we wanted to, we could add that in 45 minus 12. The 45 minus 12 minus x? 45 minus 13 minus x, I think it is. Yeah, I see what you're saying. Minus 13 minus. I don't know how useful that, but yeah, it is actually probably useful for it. Yeah, so we type these things in wrong. So I'm going to start off by thinking about this part. It wouldn't make sense if that thing has got to be greater than or equal to 0. It could obviously be equal to 0. There could be nobody who is doing just music for the after school club, which tells me that x has got to be greater than or equal to 12. And then we could either use this inequality that we've got down here, or I could just think about like all three of these things here. This total amount that we've got has got to be less than 45. It can't be more than 45. So this is 13 plus 12 plus x minus 12. 13 plus 12 plus x minus 12. That has got to be less than or equal to 45. If it was equal to 45, obviously this part down here would be 0 and there'd be no one doing nothing. So these 12s cancel, we get that 13 plus x has got to be less than or equal to 45. And when I take away that 13, we get 32. So we've got these two parts of the inequality, which is that x has got to be in between 12 and 32 for this question. Lots of different ways of thinking through that one, but just kind of like a logic-y type one for this part. And then part B, it says one of the 45 students is selected at random. Event A is the event they take art. Event B is they take part in music. Determine whether or not the events A and M are independent. Now, for the A and M part that we've got here, for things to be independent, I'm going to write down if they are independent, we know that the probability of A multiplied by the probability of M is the same as the probability of A and M. And it is kind of like a bit like a proof by contradiction kind of thing. If you've done year two stuff, you'll know what I'm saying with this. It's almost like we assume that they are independent, and then we kind of go through it and see if there's any issue. Obviously, we're not going to do this with like a formal kind of part like this. So I'm going to just figure out the different probabilities. I'll find out what's the probability of A. Well, we know that A is 25 out of 45. The probability of M, well, the amount that M we just said is X, which is X out of 45. And we know that the probability of A and M from the diagram is 12 out of 45. So I'm just going to calculate what is the probability of A times by the probability of M. So that's 25 over 45 times by X over 45. That is 25X. I haven't done any simplifying at all. 45 times 45 is 2025. Now, if these things are equal to each other, then we could have that they are independent. But 25x over 2025 is equal to 12 over 45. And I'm just going to solve this for x. So I'll do 12 over 45, times it by 2025, and divide it by 25. This gives me that x is equal to 21.6. So this tells us they are only independent if x equals 21.6. And what's the issue with this part that we've got here? What's the issue with 21.6? Yeah, it's not a whole number. And we're obviously referring to the number of people. We can't have the number of people taking part in music be a decimal part of a person. Thank you to Bryce and KR9 for that. So if they are only they are only independent of x equals 21.6, and x must be an integer. So I'm going to say so. I know it's a bit off the page. So it is not possible for them to be independent. Okay, we'll double check we've got this all right. Yeah, it's not possible for them to be independent. We've got the 21.6. They did a slightly harder method on the right-hand side for it, where they're doing it with y equals 9.6. Well, I say harder, just longer for that. And for some reason in the mark scheme, it hasn't got those correct inequality symbols that we should do. Okay, we're going to do one more statsy question before we do a very hard question that you can also be prepared for and ready for this. Now, I kind of picked this question because this particular topic about distributions is not really taught very much when I was teaching in schools, and I've only got a little bit of videos about this, but I just thought it'd be a good opportunity, just in case you get something like this in the future, you then know, how to do this. So it says Julia selects 3 letters at random, one at a time without replacement from the word variance. The discrete random variable x represents the number of times she selects a letter A. Find the complete probability distribution of x. Now, this sounds more sophisticated than it actually needs to. When it talks about finding the complete probability distribution of x, it's basically saying, what's the probability of all of the possible outcomes for it being the number of times she selects the letter A? She's picking 3 letters from the word variance, okay? So she's either going to pick, I'm just going to do this for the word variance. It goes VARINCE. That's just how I do it to count. I don't know why I do it like it's a list. So for the ones where there's selecting an A, there are 2 out of, what is this? 1, 2, 3, 4, 5, 6, 7, 8. So the A's, there are 2 out of 8, and the ones that are not A's are the 6 out of 8 that we've got here. And she's picking 3 letters. So there's only 3 different outcomes that she could actually get. And those 3 outcomes I'm going to represent with X. She could either get no A's from 3 picks. She could just get 3 of these letters. She could pick A once, or she could pick A twice. She cannot pick A 3 times because it's being removed after it is being selected. It is not being put back in to the whatever it is, the bag or whatever that's happening. And then when we're talking about a probability distribution, it's where you have these tables where it looks kind of fancy, but all it's really saying is this. You have the outcomes that you can have, no A's, 1A or 2A, and then we have the probability that X is either 0 A's, 1A or 2A. And we're just going to find these 3 probabilities that we've got here. So let's start off with probably the easiest one is to say, what's the probability that she does not pick an A? Well, in total, there are 8 letters. So on the first pick, she can have an option of one of these 6 out of 8. This is where X is equal to 0. In other words, no A's at all. So she can pick one of these 6 letters, but then after one of these letters has been picked, there are no longer 8 letters, there are 7 letters. And after the second one is picked, there are no longer 7 letters, there are 6 letters. Now, because we're saying that she's going to pick not A 3 times, that means that there are 6 that she could pick from. After one of those has gone, there will only be 5 that are not A. And then after another one of these has gone, there will only be 4 left that are not A. Okay? And so I'm saying, what is this? How does this make sense? I don't understand what's happening here. This is me saying, when I do an A with a dash, this is me saying, I'm not picking an A, I'm not picking an A, and I'm not picking an A. The probability you don't pick an A first is 6 out of 8, then 5 out of 7, then 4 out of 6, because each time there is 1 fewer letter and there is 1 fewer not A letter. So I will very quickly just do this on my calculator. The way I do this on my calculator is probably quite strange to you. I do 6 times 5 times 4 divided by 8, divided by 7, divided by 6. I just can't be bothered with using the fraction button. And we get 5 out of 14. So this one here is 5 out of 14. And then this is where we really need to understand what is happening. You can do it without, you could do some cross-cancelling, someone said. This is where you need to understand really about probabilities. The next one is saying that she is going to be picking one letter A. Now let's think of the ways you could get this. You could pick a letter A, and then you could not pick a letter A, and then not pick a letter A. Or you could not pick a letter A, then you could pick a letter A, and then you could not pick a letter A. Or you could pick a letter that's not A, pick a letter that's not A, and then pick a letter that is A. Now, all 3 of these things are going to have the same probability, okay? Because there's only one A that is being selected. It doesn't actually matter about the order. But because there are 3 ways this can happen, I am going to triple my probability to take into account that there are 3 different ways that this can occur. I'm going to just start off with doing the top one. So the probability of picking an A, well, there are 2 out of 8 which are an A. And then just like before, after one of them is picked, it's going to go from a 7 and then to a 6. But here it's a not A, and only one of these were picked. So there are still 6 for the not A's. But then after one of those not A's has been picked, there are no longer 6, there are 5 of them. I'm tripling it because there are 3 ways that this can happen. So I'm going to just do my very strange way of doing these things in my calculator. I'm going to be doing the 3 times 2 times 6 times 5 from the numerator, divided by 8, divided by 7, divided by 6, and that gives me 15 over 28. So I've now got that this is 15 over 28. Now, there is a shortcut to finding out the last probability. How could I find out the last probability in the quickest way in this question? But I'm going to do the long way as well, just to kind of show you what I'm talking about. This is now selecting A twice. How could I do it in a quicker way? Just giving people a bit of a chance to write that in the calculator. Yeah, I could just do 1 minus that, and I'll use that as my method to check it at the end. But picking 2 A's, you could pick A, not A, not A, not A, A. So in other words, there's 3 ways of doing this. Picking an A is 2 out of 8. Then after one of the A's is gone, it is now 1 out of 7. And then for the last one, how many of them out of 6? Well, all 6 of them are not A. So you actually are just multiplying by 1. Shouldn't do anything very interesting at that point. But I will do my 3 times 2 times 1 times 6, divided by 8, divided by 7, divided by 6. And I do get the 3 out of 28, which I will check is the correct answer up here. I'll just do 5/14 plus 15/28 plus 3/28. I do get that they add up to 1, so I know I've done that part correctly. And then part B of the question is kind of strange because it feels like it should still be to do with this kind of probability, but it shifts quite quickly. Yuki selects 10 letters at random, one at a time with replacements from the word deviation. Find the probability that he selects the letter E at least 4 times. So there are a fixed number of trials. Because each time it is being put back in, there is going to be a fixed probability that the letter E is selected. What other bits do I need to think about? It's independent each time because it's being done randomly. And what's the last thing? I can see someone in the chat has said it already. This is like an example of a binomial. We're doing something multiple times with a fixed probability. So I'm going to say that Y, which is going to be the number of times that E is selected, has a binomial distribution. And this is being done, the number of trials is 10, and the probability that E is going to be selected is a 9. So we're not going to be doing any of this work up here at all. This is just going to be something that is going straight in with using binomial. And we're trying to find out the probability that Y is selected at least 4 times. Now, my graphics calculator, I think, does this kind of straight up for this. And then I'm going to answer that other question that's just popped up. So on my graphics calculator, I can do greater than or equal to 4, I can say is between 4 and 10. The probability is 1/9 here. Now, if you don't have the graphics calculator, I'll show you the way this can be done. So it's 0.0184. Of course, if you did not have the graphics, we could say that this is the same as 1 minus the probability that Y is less than or equal to 3, because that's the way that the ClassWiz calculator would calculate this for you. And then Helena says, does the order matter only because they are not being replaced? So if they were being replaced, would you do it differently? No, actually, if they were being replaced, it would still be the same kind of process. You'd just be able to triple it for these ones that we have here. But if they were being replaced, it would actually become a binomial kind of question. So because they're not being replaced, that's why we have to kind of write them all out manually like this. But if you, just would be like slightly simpler kind of probabilities, we could do the whole thing using binomial instead. Okay, so let's have a look at really the question we all should have come here for. I've got all of the probabilities correct. I can see from the mark scheme, which is this. So if you're only here for this one question, this is really going to be the question that I wanted everybody to kind of see. And this was submitted to me by Isaac on Discord. And this is a really good question to go through. Oh, and Isaac's here as well. Very good, Isaac. Thank you. So this was an excellent question, and there are many ways you could do this. One of the ways you could do it is just brute force, but it gets really, really confusing really quickly. So I'm going to try and point out some things. Look, you're never going to, I don't believe you're ever going to get an 11 marker like this. But what I want to point out are some little tips as we go that are just excellent tips to use throughout these kinds of questions. Now, I'm just going to remind us of the addition formula for tan. We know, and this is just from the formula book, that tan of A plus or minus B is tan A plus or minus tan B all over 1 minus plus tan A tan B. So that's just from the formula book, and we'll be using that in this question to help us, okay? So we have tan of x plus y is equal to 2 tan of x minus y. This is very confusing, this question, because we have so many tans and so many x and y's in this one. So let's just use the addition formula on the left-hand side, and I'll try and give myself as much space as possible in these questions. So instead of a and b, it's going to be tan x plus tan y, and that is all going to be divided by 1, because it goes minus plus, it's the opposite, it's going to be a 1 minus tan x tan y. And on the right hand side, I'm just going to leave the 2 because it's multiplying by the whole thing, or just by the numerator. It's going to be the opposite. So instead of it being a plus and a minus, it's going to be a minus and a plus. So it's going to be 2 tan x minus tan y, all divided by 1 plus tan x tan y. Now, I think it feels natural. It's like the only step that we can take in this question is to get these like fractions kind of gone. Let's get this denominator and multiply it up to the right-hand side. And let's take the other denominator and multiply it up to the left-hand side. This is now from pure A2. This is the trigonometric stuff from chapter 7. So what I'm going to do is I've now got the left-hand side is tan x plus tan y being multiplied by 1 plus tan x tan y. And the right-hand side has a 2. It has a tan x minus tan y. And it has a 1 minus tan x. Is it going to fit? Tan y just about fits on the page. And then we're going to do some expanding of the brackets very, very carefully with this, okay? So I'm going to multiply everything in the first bracket by 1 to begin with, then I'll multiply it by this. So when I multiply the first bracket by 1, I get tan x plus tan y. Then I'm going to multiply everything in the first bracket by the second part of this bracket, which is tan x tan y. So I have a tan x times tan x tan y. That's going to be a tan squared x tan y. So that is a tan squared x tan y. And then I have a tan y times tan x tan y. That is going to be a tan x tan squared y. Now on the right-hand side, I'm going to leave the 2, and I'm now going to do a bit of expanding with this part. Again, I'm going to multiply everything in the first bracket by 1, okay? So I'm going to have tan x minus tan y, the easy bit. Now I'm going to multiply everything in the first bracket by the tan x tan y, the minus tan x tan y. So I have a tan x times a minus tan x tan y. That's going to be a minus tan squared x tan y. So then this is the bit where I know it's not going to fit in, so I'll just do it in the line underneath. I then have a minus tan y times by a minus tan x tan y. That's a minus and a minus, so it's going to become a plus, and it's going to be a tan x tan squared y. Now let me just point out a few things that I've tried to do consistently in this. I've always written the tan x followed by the tan y. I've always kept it in that particular order because it just kind of makes sense in keeping things organized here. Now what I'm going to do is I'm going to spot that there's actually quite a few things that are in common. Like I've got tan x's on both sides. I've got tan y's on both sides. I have tan squared x tan y and tan x tan squared y. So if you want to, this next line, I wouldn't do this next line. I'm just going to multiply everything out by 2 and then collect things. I probably would just collect things straight away here, but I'm going to do it a little bit slower just so that we are all on the same page. So I'm literally copying out the left-hand side exactly as it was before, making sure I don't replace any x's with y's or anything, and I'm just going to expand everything on the right-hand side. So I have 2 tan x minus 2 tan y minus 2 tan squared x tan y plus 2 tan x tan squared y. And then I'm going to collect together the like terms. Now, to me, it makes sense that this minus 2 tan y, I'm going to add it onto the other side because it's a negative one. And this one, I'm also going to add onto the other side because there's a negative and it will match with this one, which means I can take this tan x, I'm going to put it to the other side, I'm going to subtract it, and I'm going to subtract it like that. That will just keep everything positive in a nice kind of way. This is generally a good way to think about manipulating these kinds of things. So I'll do the tan y plus the 2 tan y, which is going to give me 3 tan y. Okay, so I'm just going to kind of indicate that I've dealt with those ones because that's another way of like a good technique of making sure that you're not dropping anything that's important. And then this minus 2 tan squared x tan y, these are like terms. So I'm going to add this to this side, which gives me a 3 tan squared x tan y. And I'm just going to indicate that I've done those so that my brain knows, great, those are dealt with. Now, if you thought the first part of the live stream was easy, we've obviously got a much harder part here, haven't we? I didn't underline these bits in purple, but these are the bits that are going to go with these ones. So I have a 2 tan x. I'm going to move that one here. So I'm going to do 2 tan x minus tan x, which just gives me a tan x So I can deal that I've done those ones. And my last one is I have 2 tan x tan squared y minus tan x tan squared y, which is just going to be plus tan x tan squared y. Now, here is something that is just broadly an important thing to think about in these kinds of questions. What do you notice about the left-hand side? What do you notice about the right-hand side? Is there anything that you just algebraically, you look at stuff on the left-hand side and you go, oh, that's interesting. Or anything on the right-hand side where you go, oh, that's interesting. I'm going to do something with that. And I can have a drink of my water because it's a tiring question. Really hard to spot. I'm going to suggest it, but this is always a good kind of thing to focus on. Yeah, if you can spot what Breezy has just said, that they can be factored, that's always a good thing to do in maths. If you can factorize something, that feels like a smart thing to do. So the left-hand side, they both have a 3 tan y, and the right-hand side both has a tan x. So if I factor out a 3 tan y, that would leave me with a 1 plus tan squared x. And on the right-hand side, if I factor out the tan x, I have 1 plus tan squared y. Now, this is where you need to have these things memorized. If you don't know what 1 plus tan squared and 1 plus tan squared is, you're not going to be able to see this shortcut that saves so much in this question. Now, I know that 1 plus tan squared, I wonder if I can just jot this down. I know that 1 plus tan squared theta is sec squared theta. So I can replace this and this with sec squared. So that is 3 tan y multiplied by sec squared x. And then on this one, I get tan x sec squared y. It's looking so much neater, and like we're actually kind of working through towards what we're aiming for. Now, the thing we're aiming for, I'm going to jot it down here. We've got that sine 2x over sine 2y is equal to 3. You can do a little bit of this kind of moving around. Now, I know that the line before this is going to be like sine 2x is 2 sine x cos x, and sine 2y is 2 sine y cos y equals 3. So those 2's are gone. So if I can make this whole question look like sine x cos x equals 3 sine y cos y, then I've done it, because I can just divide by the sine y cos y, and I've got the thing that I'm looking for. So I might need to come back to this in a second. Right, I'm now going to move away from tan and sec, and I'm actually going to get it into sine and cos, because that's clearly what I need to get it to. So this is going to be a 3. Tan is sine over cos, so that's sine y over cos y. And sec squared is 1 over cos squared x. On the right-hand side, we have sine x over cos x, and sec squared is 1 over cos squared y. Now, I knew this stuff was going to get in the way, but I'm going to see if I can do this all in one go. Clearly, this line that I've got right here has no fractions in it, whereas this line has fractions in it. So I want to think to myself, what should I multiply everything by that gets rid of the fraction? And the thing that I'm going to multiply by in this question, I need to multiply by cos squared y to get rid of this one, and I need to multiply by cos squared x. If I can multiply by cos squared x, cos squared y, I should get everything cancelled out from fractions. So I'm going to multiply by cos squared x, cos squared y. Obviously, this is a super challenging question. Now, if I multiply by cos squared x, cos squared y here, cos squared x will cancel this, and if I times this by cos squared y, I will have sine y, cos y. So I have 3 sine y, cos y. And if I multiply this side by cos squared x, cos squared y, when I multiply by the cos squared y, this part goes. And when I multiply sine x over cos x by cos squared x, one of the cos's cancels and I get sine x, cos x, which is this line that we have here, which then can be written in the division form like this, which is the same as this kind of one. So I know it's got a little bit sneaky the way I've kind of done that at the end. I perhaps should have left myself more space, but there's a few different points I wanted to illustrate here. One, it's about using a lot of space. The other thing is about being organized and thinking to yourself, okay, let's put the like terms together. The most important step that simplifies this whole problem is to factorize. If you see something in like a proof kind of question, factorizing is incredibly important. The second you see this 1 plus tan squared, you go, oh, I recognize that. I needed that with something. And memorize stuff, memorize this kind of thing. And then obviously I did a little bit of working back here to just check I was on the right direction with this kind of thing. But it's an incredibly hard question. This is not something that would have been in an exam paper. I can't imagine this being in an exam paper. But it was definitely a tough kind of one. Now let me see if I've kind of missed anything in the chat that we've got here. You can see that we've got some discussion around going through some of the extra videos and stuff. Super difficult kind of question. You might try it in your own kind of way. You might come up with a different approach to this one. Now, my last one that I'm going to have a look at is a further maths question. However, I really want you to stick around if you are not doing further maths because there is so much to gain from this in doing, there's only one part of it that feels further mathsy, and I will kind of like tell you which part of it that is further mathsy. Yes, that is correct for your reasoning in that bit, Breezy. You could write the reasoning for the lack of twos in the fraction because they cancel out. So you don't even need to kind of show that. That's absolutely fine. Okay, so do stick around for this one, even if you don't do further maths, because part A is not further math, part B is not further math. It's only part C that has a little bit of further maths to begin with, and then it's mostly integration. And then part D is really why I think this question was submitted on Discord, because it's super tough and it's just going to be a nice way to end this kind of live stream. And it's probably going to take me about 15 minutes to do this question. So it says figure 1 shows the central vertical cross section ABCD of a paddling pool that has a circular horizontal cross section. Okay, it's a cross section of a circular paddling pool. Measurements of the diameters of the top and bottom of the paddling pool have been taken in order to estimate the volume of water that the paddling pool can contain. Why they wouldn't just fill it with water and measure how much water there is, I don't know, but whatever, it's maths, here we are. Using these measurements, the curve BD is modeled by the equation y equals ln of 3.6x minus k, and x is between 1 and 1.8. So if I just kind of go to this, but I don't know if you can even see my menos when I do this. No, you can't see, there's no point in me even gesturing to it. But on the diagram, if I do a quick sketch of this, we are saying that this curved part is representing between D and B. It is saying this part here is where x is 1, and this part is where x is 1.18. Okay? So, I know that's not really come up very clearly on the diagram. It's gone a little bit out of focus, but it should be all right. First thing we want to do is to find the value of k. Well, clearly, this point that we've got down here has a coordinate, and that x coordinate is 1. And the y coordinate is 0. So we know that that coordinate is 1, 0. In other words, when x equals 1, y equals 0. So we can use that with our equation, which is y equals ln of 3.6x minus k. We can use that to find out what k is equal to. Okay? I'm very good, Matto. Thank you so much for asking how I am. Yeah. So I'm going to say y is 0. And x is 1, so we get 3.6 minus k. Now, this is applicable to anyone. What does 3.6 minus k have to equal? The ln of what is 0? The ln of what is 0? Or you could do it using exponentials, but I think it just kind of, to me, it's about memorizing what some of these things are. Yeah, so it's ln1. So I know that the 3.6 minus k is 1. So doing a bit of rearranging, k is 3.6 minus 1. Which is 2.6, okay? And then part B says to find the depth. Okay, well, I think it's to do with this point up here. If I can find out what this point up here is, the y coordinate of this point, then that must be the depth of the pool. So I want to find y when x equals 1.18. So y would be the ln of 3.6 times 1.18 minus k, which is 2.6. So finally changed my batteries in this calculator. It kept in that thing where it's like, change your batteries, and I just ignored it. But I've finally done it. And we get 0.49956 blah, 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 which is 0.500 meters to 3 significant figures. This seems like a reasonable depth for a paddling pool, not for a swimming pool. but for a paddling pool that we've got here. This was your question to Drew Patel. Yeah, the mark scheme, I would definitely get to part D because that was the hard part. But I think these parts are quite nice for people that don't do further maths. Having said that, we're about to do the further maths part of this question. The pool is being filled up with water from a tap. And it says, find in terms of H the volume of the water in the pool when the pool is filled to a depth of H meters. So if this is kind of like part of the paddling pool, we're now just going to be filling it up to a depth of H meters. Now, if you do further maths, we know it's a volumes of revolution question, but once I've done the first setup of this, you'll all be able to just follow along with the integration if you've done this, okay? So normally we would be integrating it between 0 and the y coordinate, but this time we're going to be doing it between 0 and the y coordinate, which is going to vary. It's going to be h. And it's usually pi, the integral of, because we're going around the y-axis for the volume of revolution. Don't worry, this is the further math stuff. It's pi of x squared dy, and it's between 0 and h. So I just need to figure out what the x squared part is. So I'm going to take the formula, which is that y equals the ln of 3.6x minus k, which is 2.6. I'm going to make x the subject of this and square it. So to get rid of the ln, I will do the exponential. So that's e to the y equals 3.6x minus 2.6. So it is e to the y plus 2.6. That whole thing is going to be divided by 3.6 to give me x. But because I want x squared, I'm going to square everything. So 1 squared is 1, 3.6 squared, and e to the y plus 2.6 all squared is x squared. So let's continue with this part. I am doing pi. I'm going to take this 1 over 3.6 squared. I'm going to take that to the front. So I get pi over 3.6 squared, the integral between 0 and h of this thing being squared. Now you can do this, whether this is now, and that the rest of this question is now normal maths, okay? The third maths part with all here is done. So I'm now going to do this part squared. When you square e to the y plus 2.6, e to the y times e to the y is e to the 2y. I then have a 2.6 times e to the y, which is 2.6 e to the y, but I get that twice. And 2 lots of 2.6 is 5.2 e to the y. And then my last part would be the 2.6 squared that we've got here, okay? I'm just laughing because someone said, was I at the O2 on Saturday? No, I wasn't at the O2 on Saturday, but that's brilliant. I want to know what you were seeing at the O2, what you were doing that you thought, oh, maybe that's Mr. Bicen. I'm up in Manchester. So I was definitely not at the O2. Yeah, I was down in London at the weekend, but no, I wasn't at the O2. So I'm now going to do the integration. This is something that is for anybody, not even further maths people. I'll leave the pi over 3.6 squared, and I'm going to start integrating these things. So we have e to the 2y. Well, that's just going to integrate to e to the 2y. But we have the half because we're trying to counter the extra 2 that's coming from the y. The easiest thing to integrate, 5.2 e to the y just goes to 5.2 e to the y. And the second easiest thing to integrate, 6.76 goes to 6.76 y. And that is between 0 and h. So I'll leave the pi over 3.6 squared here. And then when I sub in the h, I get a half e to the 2h plus 5.2 e to the h plus 6.76h. Then when I sub in 0, I'm going to be subbing in 0 to here and here. When you sub in 0 to the exponential function, you get a half e to the 0, which is just a half, and you get 5.2 e to the 0, which is just 5.2. It's 5.2 times 1. So I'm going to be subtracting a half, and I'm going to be subtracting 5.2, which now gives me that the volume is pi over 3.6 squared, a half e to the 2h plus 5.2 e to the h plus 6.76h, and then a half and 5.2 is minus 5.7. What a delightful question. It's ridiculous, really, isn't it? Ridiculous kind of stuff. So I'm going to leave that there because we're definitely going to need that. Now we are finally on to the super hard part of this question, okay? Part D. Let's try and even work out what this is. And this is top end stuff for maths here. Given that the pool is being filled at a constant rate, oh my gosh, when you hear the word rate, what does it make you think of? See if you can tell me what that makes you think of. So the constant rate of 15 litres every minute. Find in centimetres h to the minus 1 the rate at which the water level is rising in the pool when the depth of the water is 0.2 meters. Yeah, differentiation. This is definitely connected rates of change and stuff. Now, the reason this question is so bonkers is because I think they've got the units are crazy in this question. There are so many different units. I'm just going to quickly list them. We have liters, minutes, centimeters, meters, meters cubed, and hours. This is a ridiculous thing. So the first thing I want to point out is it says find in centimeters h to the minus 1. That is not centimeters and then the h to do with the paddling pool. That is to do with hours. So we're finding it in centimeters per hour. We want to find the rate at which the water level is rising. Now the water level is h, so we want to find dh dt. This thing, dh dt, they want it to be in centimeters per hour, which is super annoying. Now, we know when we do these connected rates of change, we split it into two things. We're going to have it as a dh d something and a d something dt. Now, that missing variable has got to be the volume that we've talked about in the previous part of the question. Let's just quickly go through and think about what all of these things are being measured in. The volume in this question is being measured in meters cubed, and the height was being measured in meters in this question. So I actually think we can do ourselves a bit of a favor. Let's work out dh dt. Instead of doing centimeters per hour, let's do it in meters per hour. And then at the end, we'll convert it. Now, dh dv, well, dh, this is in meters. dv is meters cubed. The volume is in meters cubed. But we need to make sure that this dt in this question is matching what we want it to be over here, which is in hours. So I'm going to start off finding the dhdv. We've actually got what v is over here, so we need to find out what dvdh is. Now that sounds like we're going to have to do all of this differentiation of this thing. However, because we integrated to get this thing here, we can just go back to the original question, because this must differentiate, or not, sorry, this must differentiate to this part that we've got up here. So I can save myself a bit of time and just say that it is pi over 3.6 squared e to the 2h rather than 2y plus 5.2 e to the h plus 6.76. If you didn't spot that, it's actually really easy to differentiate this. You can see that differentiates to that, that differentiates to that, and that differentiates to that, and that goes. And we've been told that h would equal to, in this question, 0.2. So on my calculator, I will find out what dvdh is by subbing in 0.2. So I will do pi over 3.6 squared, one of the few times I'll use the fraction button. And then it's going to be e to the 2h. So that is e to the, 0.4, because that's 2 times the height. And we have plus 5.2 e to the h. And then we have plus 6.76. So we have this 3.5398959, blah, 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 like this, okay? In a moment, I'm going to take the reciprocal, and then I've got that part. This is now the thing I want to think of here, the dvdt. They tell us in the question that it is 15 litres per minute. I want the question to be in meters cubed per hour. So first of all, let's multiply it by 60. 15 times 60, 15 times 6 is 90, so it's 900 litres per hour. Now I'm also going to convert, I need to know the conversion between meters cubed and litres here. So meters cubed and litres, I know that 900 litres, no, I'm going to start with meters cubed. I know that 1 meter cubed is 100 cubed centimeters cubed, which is a centimeter cubed is the same as a milliliter. So it's 100 cubed milliliters. 100 cubed is a million, right? So if I do that and I divide it by 1,000, it's no longer in milliliters, it is 1,000. 1 meter cubed is 1,000 liters. So it's going in at 900 liters per hour. and I need to convert that into meters cubed. So in meters cubed, it would be, and this is going to be in meters cubed per hour, it will be 900. This is 1 meter cubed. It would be 900 out of 1,000, which is 9/10 or 0.9. So that is the rate at which the paddling pool is being filled in meters cubed per hour. Really, really hard conversions of stuff. So my final part that I need to do for this question is literally to just answer it, that DHDT is DHDV, which is the reciprocal of this one, 1 over 3.5398, times it by 0.9. That's not actually the end of the question, though. 1 divided by 3.5398959 times it by 0.9. And this is my 0.2542. But remember we said this was in meters per hour. They want it in centimeters per hour. So times it by 100, which is 25.4 centimeters per hour. Crazy question. And that has taken us to, I'm not going to do the last question, but that has taken us to the end of the live stream as well. Now, I probably might have missed some things in this bit. That's so funny. Okay, I'm just laughing at someone looked like me on the crowd camera when you've gone delusional because of too much revision. That is hilarious. I need to figure out what was on at the OT, what kind of event you thought I might have been at. But what did Breezy say? Isn't it just easier to find the HDB and then multiply that dVdt within converted units? I feel like adding the units makes it more complex. Maybe, but I found this like hard, the units. I really had to break the units down in this particular way. I'm not quite sure what you mean by that, Breezy, but hopefully, I don't know, maybe you can explain it a bit more, just so that other people can kind of know a bit what you're talking about. Anyway. Yeah, only 3 marks. Isn't that bonkers? All that thinking difference. And it's actually from a real paper. It was from 2019, which was the first year that further maths was ever sat. And I mean, isn't that evil? I remember my students, my first further maths class of the new spec, coming out and being like, the exams were really, really, really hard, sir. And they totally were. They were crazy. I am going to try and do some more past paper walkthroughs as well. Yeah, super, super hard question. Imagine getting this in your exam. Horrible. I wouldn't have got this. The thing that tripped me up when I first saw this was it says centimeters h to the -1. I thought it was referring to h in the previous bit of the question, but it's not. It's referring to hours. Why can they use different letters? It's so confusing the way that they do all of this stuff. Okay, so if you do have any other questions, I'm going to wrap this up now. But if you do have any questions, I'm very happy to kind of stick just for a couple of extra minutes and answer any of these questions. I am doing a video that's a bit like a kind of summary of my year if you want to check that out anytime soon. If you're interested in the Bicen Maths Award as well, there's an opportunity for you to win a scholarship with £150 and a graphics calculator, and there's 5 people who are going to be awarded that. So if you haven't checked that out, that is on my channel homepage. Just search Bicen Maths Award and that will come up. It's open to absolutely anybody in year 12 and year 13, and I'd love to see even more applications. It's been going really well so far. People are already applying, but the deadline is at the end of January, so you still have a good few weeks to do this. When do I think I'll have the summaries for year 2 finished? I will definitely have all of the pure ones finished by the Christmas holidays. I really want to get the pure ones finished in the next couple of weeks. I'm going to be working hard on those ones. And then when I come back to the applied, I don't know, there's fewer applied chapters, so it should, in theory, be a little bit quicker. But pure year 2 should be finished by the Christmas holidays, so you can use them over the break as well. I might be doing some core pure summaries as well. This is a massive job. I know it doesn't look like a big job because they're like 20-minute videos and there's just a few questions, but I'm pulling in all of my knowledge from the assessment, from my teaching, and thinking if I could only give 3 examples on this, what 3 examples will I give and why? And then I need to design them from scratch because I don't want to use exam questions because it's not an exam question walkthrough. It's a chapter summary. So I'm having to make sure that it's very well designed. So if I can do it for core pure, I will, but it's, I've got to balance it with all of the other projects that I've got working on that are happening behind the scenes as well. Okay. Oh yeah, what did you say in the last message? So from the DHGV times dVdt, you got the 3.5 like you did, but for the second part, you can just spot the dVdt is that. Yeah, my brain just didn't see that though when I looked through that, but I do agree with what you're saying. So guys, thank you so much for coming along to this live stream. It was a quieter one than usual, but in a way, I hope that means that you felt like you've had an opportunity to kind of ask some questions and be heard. Sometimes when they're really, really busy live streams, it's quite difficult to kind of have your voice heard. So if you did have anything today that I didn't answer, I'm really sorry. Sometimes it's quite hard to kind of keep an eye on the chat as well. Oh, I just saw that Triggered was like, wasn't it supposed to be centimeters per minute? No, it was supposed to be centimeters per hour. It does say in the question centimeters per hour, which is kind of annoying in the question as well. Yeah, I enjoyed this quiet stream. It was nice. I mean, I think in the one I had in the summer had like well over 1,000 people. So get in these quiet ones while you can. It's just like a bit of like extra tutoring or going through some stuff. And not many people are submitting questions. I would love it if people were going on the Discord and submitting questions. If you don't want me to like mention your name in it and you just want to submit a question, say, oh, please don't mention my name on the thing. It's fine. We'll just use like a different username. Because those two questions that were submitted, the last two, were definitely the most interesting. But I think you all would have turned off the live stream had I started with this. In fact, I'll kind of leave it on this nice page that we've got here. Guys, thank you very, very much. I am going to close this live stream down now, which is a bit I always forget how to do. So I'm going to just wrap it up. I hope you all have a great last couple of weeks at school. Don't work too hard. Have some fun as well. I'll see you all soon.